I guess compressed air as a service came about when you look at the overall cost of of compressed air generation, and 80% of that is energy.
Hmm.
Um, so compressed air as a service, basically, um, air is generated and sold per meter cubed, but the electricity used to create that compressed air is then credited back off the monthly bill. So
Hmm.
it keeps um, it keeps us responsible for the generation of compressed air. So it's in our best interest to create the most efficient system and constantly tweak that to make it more efficient and rebuild and repair as as needed to keep that efficiency on track. Because it is such a big portion of compressed air generation that we're now responsible for.
So because if
Um,
you take on with it as a service, if you take on the entire ownership, maintenance, service, and ongoing sort of production of the air, um, and you're fully responsible for the production of the air, then you're sort of fully incentivized to run it as efficiently as possible, to be proactive with the maintenance, and yeah.
yeah, yeah. And second to this, the second component of compressed air as a service is liquidated damages. So if we do not meet our targets for pressure, for flow, for air quality, then we're then penalised. So for every minute that we don't meet those standards, so making sure the system is reliable is a huge part of supplying compressed air as a service. Having it,
What steps do you do to help ensure reliability? Is it obviously probably at the design stage? So you have built-in redundancy, but then probably monitoring as well?
yeah. So I guess that's why I'm probably involved as opposed to just a regular engineer. Um, because we need these things to last for 10 years, and I've spent so much time on site maintaining and fixing. I've seen problems and I know how to get around them. So, there's a consensus in, the industry to make things as efficient as possible, which is good. But if that efficiency only lasts for a year, it's kind of worthless. So you have to build a system that's a bit more bulletproof and a bit more reliable. So taking some of that into consideration, yeah, more adaptability with control, allowing for expansion, allowing for reduction of flow, perhaps, isolation and bypassing of things so things can be done on the fly. Everything from auto drains to air receiver inspections, everything has to stay live. So we have bypasses and redundancy systems on those. Um,
Is that something that not all systems would get installed because they're not required for uptime?
Yeah, well, it's expense, right? So a bypass line is more material, it's more valving,
Hmm.
it's longer labor to install. So
Yeah.
things like that can get skipped, and it's like, well, you'll just have to shut it down to do an inspection. Whereas we don't want to shut down, we want to keep flow because that's what the customer needs. And if we don't supply flow, then we're penalized. So, um, and as far as the data side goes, we wanted to create a system that was how do we make it that we don't need the customer to do a walkthrough to do daily and weekly checks. Like how can we do that remotely,
Hmm.
using remote monitoring and data? So for me, a big thing is visual inspections. So we install cameras into our rooms, our compressed air rooms, so we can see water leaks from cooling water, condensate leaks, oil leaks, oil mist or steam coming off things, debris and dust, anything like that. Um, then we start to move into individual compressors, and you look at your daily and weekly checks, and you think oil levels, coolant levels, temperatures. So we install oil level monitoring. Some
Is that
sites we
something
even
that's not always installed if you do a new compressed air system?
uh, I've never seen I've never seen people monitor it. There's basically a sight tube on the side of the compressor that you open up the cabinet and have a look.
Hmm.
If there is a sensor, whether people actually do that with the data, you're flat out getting any kind of comms connection because again, it adds costs and
Yeah.
complexity.
Hmm.
And a lot of the time, a site will be commissioned, and due to time restraints, they'll try and get communication set up, and whether it's polarity on cabling or programming or
Just a
the
lot of
customer
bugs to
side of
be
things.
rectified at the
Yeah,
end of the job.
it usually gets left, and then it never gets up and running. So and for seeing that for years and seeing like how much of data is available and what could be done, and so I was like, we want to get this out and we want to use it. So it's it takes time, but you work through it and you get it all into a platform, and then you can view it. And then when you have that data, you can see your oil levels, your temperatures, your energy in, your air out, and then you can start to track things. So you can see um, efficiencies drift away. You can see oil levels change. You can see, I think some sites we even have oil quality monitoring where we actually have live oil sampling that's done. And we can see the data on particle count and moisture content and things like that. So
okay.
yeah,
With all this, and then what sort of checks are being done, like daily versus weekly?
daily is a bit more of like walking through the plant room, I guess, kind of thing.
But if we're doing it remotely, how does that work? The daily checks.
So the daily checks, our team logs on, views the cameras, and checks through looking for items like water leaks, oil leaks, things like that. Then they have a dashboard set up where they can view all the items that you need to view for a daily check. So we'll have for compressors, we'll have each compressor with its alarms and faults present. So if there's an alarm or a fault, it'll be highlighted and say, yes, there's a fault present. We can see, again, coolant level and oil level. And then we can track the efficiency. So we can get the individual energy consumption of that unit, the flow, and then we can then group all that together and see, okay, what does that look like against the whole system? So what's our whole system energy usage? And we can see, oh, number 2 is, definitely using more energy. What's going on there? And then the weekly checks, when we start to get into, I guess, keeping track of all our metering, so make sure what we are reading is accurate, and we can verify that by looking against secondary metering, because we have redundancy on our metering and different things.
So you're basically comparing multiple data points against each other because you get some redundancy, and you can check that they're all still accurate.
Yeah.
Okay, great. And in terms of all these checks that we're doing, obviously we have a compressed air as a service project up and running. Like, could you maybe talk through anything that, like, any faults or issues that we've come across because of these checks that maybe might have been overlooked otherwise?
Yeah, we had one last week. We had there was a puddle of water outside one of the low pressure compressors. And
how do we see that?
It was on the camera. So one of our team picked it up, and it looked like it was coming out of the compressor. And I rang the customer, and I said, "Oh, I've just noticed a puddle of water. Do you mind just telling us if it's coming out of the compressor?" And he went down there, and it was actually coming out of their cooling water pumps for their own system. One of the pumps was leaking, so we actually found a problem where they weren't aware of
with their system.
With their system that had nothing to do with our system.
Through our checks, okay.
Yeah, and another one was all our server rack and computer is in their switch room, which is air conditioned, and we got an alarm saying high temperature on our server. And we gave the customer a call, and they went in there, and the air conditioner for that room had tripped, and they didn't know. So the room was up to, I think it was like 60 degrees in there. So they didn't have any way of telling that room, that air conditioner had tripped. So they went out, and they got a refrigeration technician out and got it fixed. So
yeah, okay, that's good. Anything else that we've come across around that with the checks, or things that wouldn't have picked up otherwise, but we can show that our process is actually working well and catching things?
Yeah, we had a high water pressure alarm on one of the compressors, and an alarm. They have their own internal cooling system, so it's a coolant circuit with a water pump.
Okay.
Has a pressure transducer, and it has an alarm value, but no trip value. So basically, the coolant pressure should be around about 1.6 bar, and it alarms at 1.7, and we were seeing 1.8 intermittently. So the alarm would come on and go away. And with an alarm, it's not critical, so it doesn't trip the machine or send a notification on the standard system of remote monitoring, which the manufacturer uses.
Yeah.
So these things were popping up, but was not enough to trigger anyone to look. But we were seeing it, and it took a while to find because a high coolant pressure on a system that has no adjustment and no control. It just the pumps on. We have water pressure, and it's what would cause that? And it's like, well, bad pressure transducer or restriction. So then they started looking, and they found that there was a piece of aluminium slag that was from the manufacturer of the equipment, was lodged in one of the heat exchangers and restricting the water flow just slightly. So when they pulled out the hose to test it, this little piece of slag fell out. They went, "Oh, that's not good," and then put it back together, and the fault was gone. So, and the pressure was back down to where it should be. So, that's something that unless you're standing in front of the machine watching that little light come on and off, you're not going to pick up. So,
yeah, great. I mean, I think there's probably 3 or more examples, like really good examples there of these checks and the process that we're developing to help basically stay on top of this reliability and keep the air uptime, and then obviously the longevity of the assets. Perhaps just to finish off, if you could talk a little bit just to the diagram of how utilities as a service works, what the customer provides versus what they get and what we provide. I'll just bring up a little slide here. And so, yeah, kind of got on the left what the site's providing, and then on the right what the site's getting. So it looks like they're providing obviously air, drainage, electricity, the building, the on-off signal, and the water, obviously depending on what the utility might be. In this case, if we just assume it's compressed air, and then we're getting the data coming in from the compressed air assets, and we put on a revenue meter. I'm assuming the revenue meter is that on the flow side, the electricity side, or both?
Both, yeah.
Yeah.
Do you just want me to run through all those items and talk a bit?
Yeah, that'd be great.
So for as a service sites, generally there's a few requirements we need from the customer to make this work. So water, so whether that's water to supply cooling water or lubricating water. Some units are water injected for some of the oil-free models, or it could be top up water for a cooling tower. The on-off signal is basically we still control the running of the compressors, but there is a way that the customer can actually intervene to shut it down. So we have basically a master stop that'll shut everything down and shut all the air off to the plant, and for any reason that they need to do that. So we're not locking people out to say like, this is ours, don't touch it. There's nothing you can do. If they need to shut it down, they can shut it down. And we make that very clear and very easy to understand. Fresh air. Air is a massive part, obviously, of compressed air. Supplying clean air and
what does clean air mean in terms of this system?
A lot of sites will have airborne particles, whether that's dust from a dirt road nearby that trucks use, sawdust, the absolute worst, concrete dust, gyprock, any of that sort of airborne particles that get into things. So if fresh air isn't available, we have ways to manage that. We can one of our sites, we've put 2 quite large air handling units to the room where we draw air in through bag filters, filter the air going in, and then pressurize the compressed air plant room to keep dust and particles out.
So positive pressure in that room.
Positive pressure in that room. And the other element of this is we also incorporate a heat exchanger. So we run, most of our sites are water cooled where we use cooling water. So those days where our ambient air is above cooling water temp, we will then run it through a heat exchanger, which will take the edge off that temperature. So it's a way we can cap and control air quality and temperature if needed. Drainage, so condensate, any kind of moisture or stuff that is generated with compressed air, we need it to be drained away. So usually that sites will have like a wastewater system. If not, they'll have a grey water system, and then we can treat our any condensate that needs to be treated, removing any oils or contaminants in that water, and bring it back to grey water, and then that water is then disposed of. Electricity, so we need the supply of electricity, so we're not going to be generating it, we'll be using the electricity coming in, but we meter that electricity, and that is then credited back. So everything that we use for electrical is then credited.
Okay.
And a space to put it in. Yeah, we've had some tricky spaces to work with, but yeah, we can get it done. We've done one live system cutover, and we're in the process of a second. But yeah, give us a space and we'll work compressed air out of it.
Yeah, cool. Okay, thanks very much. I think that's probably a good like high level overview of utilities and compressed air as a service. And I guess if someone watches the short video, then they got questions, they're happy to follow up with us, and we can answer any questions they might have.
Mm-hmm.
Thanks, Steve.